So I'm going to kind of jump right into this because I know we're a little bit behind and we have a few more talks. And I'm good? Oh, OK. All right. I'm getting hungry. I guess that must be it. Sorry. So I guess I'll start with Woody from Kinetica real quick here. And just briefly just discuss, I guess, how the Power Platform itself has impacted your product's performance in general.
Yeah, as others have been mentioning earlier today, one of the big advantages we have with Power is the host-to-bus communication on NVLink and NVLink 2 on Power 8 and Power 9. And what Kinetica, the company I work for, we have a GPU-accelerated insight engine. What that is we push a lot of the data processing off to the GPU. And the big limitation we have is host-to-bus. And so over an Intel-based system, which we also run on, we see between 2.5 to 4.5 times performance improvement. And what that does is that drives a lower TCO. And as Maura said from Google, that's one of the big issues we have in today's industry in the software, is that it costs so much more to get more performance. It's definitely impacting us. And what we see is with the lower TCO on Power, it's actually driving customers to be able to use our products, to be able to use us for either visualization and geospatial or OLAP engine type queries, and on the really cool stuff like AI and deep learning, that is actually driving the cost down, and it's getting more value out of the customers, and that's just a win-win for us all.
Okay. Well, and I guess I'll jump to Ari real quickly. In terms of artificial intelligence, AI, can you tell me about the different types of, I guess, AI engagements that Elinar has been doing with Power?
Thank you. So we have been doing lots of different engagements around AI, from understanding what does text mean and how business should react on whatever is being said on a text, to kind of a more what I call mundane things like image recognition, finding fraud from videos. Mm-hmm. And since we standardized all our development on Power AI, it has been very smooth going on, ramping up new developers or whatever we need to do, because we essentially take the equation, sorry, the term out, this is my mind. We are taking the infrastructure, the AI frameworks out of the question. How do you set them up and do things like that? Mm-hmm. And now we are actually facing a kind of a next bigger challenge for us, because we have launched a repeatable product on AI that can actually recognize very kind of deep things from text and extract them like privacy information, which can be highly complex. And that's something that companies are not fully prepared to push into cloud yet, which means that we have to be able to provide on-prem or very close to on-prem AI inferencing and training. And that's where Power AI comes into play, because it's so easy to kind of set up a repeatable environment where you just start running your code.
Okay, thanks. I kind of want to keep on the same AI track here. I guess we'll probably talk a lot about that. And kind of jump to, I guess, Vinod over at H2O and kind of discuss, I guess, why the Power architecture, especially the latest Gen P8, P9 servers have been suited for AI workloads for you all.
Yep. So when people think of AI, typically most people think of the algorithms, and especially the deep neural networks and associated algos, which have been accelerated. What for us, there's a whole bunch of workloads more than on top of the algorithms. So there is the data wrangling, the data munging, the feature engineering portion of it, alongside statistical learning algorithms, traditional machine learning algorithms, plus deep learning. And what each of these algos can be accelerated much more on GPUs, as we are very well aware of. But the data wrangling portion, which can happen on the CPUs, the data transfer back and forth between CPU and GPUs itself can take a lot of time. And with the P8 and P9, we've seen tremendous acceleration, because you're the NVLink connection between the system and the GPU memory. Mm-hmm. So what it means is that end-to-end workloads, from data ingest to feature engineering, wrangling, machine learning, and scoring can all be accelerated at a much higher rate. And that's what we're finding.
Okay, thanks. I guess you pass it to Ashish real quick. I want to jump into a little bit around MapD. You claim to have extremely fast SQL engine harnessing the power of GPUs. And how does that really translate into better AI machine learning output for data scientists?
Great. So thank you for inviting me here. My name is Ashish Bambroo. I lead partner business at MapD. Quick background about MapD. We are an GPU-accelerated analytics platform, and we help customers ingest extremely large data sets. We're talking about billions of records, and then be able to analyze and visualize those extremely large data sets in milliseconds. We also provide the data science community features that actually enable them to have better outputs on their ML and AI processes. And we do that as part of our involvement in the feature engineering part of ML. If you talk to data scientists about how much time they spend on data preparation versus actually running algorithms, while running algorithms is always a little bit more exciting and sexy, but it's the data preparation, the feature engineering part that really takes the majority of their time. So what MapD does is we help data scientists visually explore huge data sets that they can then use to train their models. And once you get the predictions, then it becomes notoriously difficult sometimes to really explain why the predictions are the way they are. And in that area, MapD can visually help explain to the data scientists and their customers how the predictions are actually performing. That generates more trust and adoption of AI. And finally, when you have the predictions initially and then the final outcomes, the outcomes vary from the predictions. And over a period of time, that variance actually increases. And our platform helps data scientists to overlay predictions and actual outcomes and be able to then take that in a feedback loop and retrain the data and get better predictions over a period of time.
Okay. I'm going to jump to Richard real quickly. And before I ask, I mean, congratulations. I guess you guys recently announced a partnership between BrytLyt and MariaDB.
Yeah, MariaDB.
Yeah.
Very, very excited about that.
I mean, I'm coming from Ubuntu in the software world. I know how popular MariaDB has been exploding recently, right?
Sure.
And I guess, what I would want to know is how, I guess, that partnership between you all fits into like the whole AI space.
Sure. So just to start with, BrytLyt is a technology that uses GPUs to massively accelerate SQL relational workloads. We've already integrated with Postgres, but it's the partnership with MariaDB that we're really, really excited about, because it means that we can now use that as a vehicle or mechanism to get our technology into the hands of literally millions of users, right? So really excited about that. But, SQL and relational workloads are not that well suited for the machine learning and AI space. They're used a lot, predominantly for data prep, and the comment earlier was, a lot of the data scientists' time is actually spent in data prep. I think it's something like 66%. And so what we've done is we've looked at some of the frameworks out there, like Google TensorFlow and Torch, and integrated really tightly with Torch. In fact, we've taken the memory management module from Torch, extended it, enhanced it, and that's what we use for memory management from the BrytLyt, from the SQL side. And that means that as far as the computer is concerned, the stuff that you're using to create tables and columns is the same stuff that you can use for creating tensors. And the really powerful outcome of that is you can now have zero copy. You can use an SQL workload to prepare your data, straight out of that, consuming literally the same piece of memory into a Torch framework for your AI and machine learning workloads.
Okay, thanks. Probably jump to Woody really quickly here. And earlier they were talking about switching over to Power from Intel-based architecture. And what has your experience been in terms of operationalizing your product on Power?
Yeah, that's a really good question. As the speaker earlier from Morgan said, from Morgan State, one of the big differences is just compiling and packaging. That's the biggest difference we have, is from how to run on Power. We just go and we compile, We did have some specific things that we changed before, specifically around the memory management, but we're good to go. The other cool part is all of our scripts, because we run on Linux, all work the same as well. And so what that does is that allows it significantly easier to run our product on Power or on any other framework, because it's essentially the same.
Okay. I want to go to Richard real quick again. Sorry, I want to ask a question. I noticed, I guess, in a recent third-party benchmark last year that you guys are basically the fastest GPU database on the market by quite some margin.
Yeah, quite some margin.
From your point of view, though, what are the challenges that you are seeing in the accelerated GPU database market today?
Sure. So we all know that GPUs are really good at accelerating data, and it's a fantastic new technology for accelerating SQL workloads, machine learning workloads, all those kinds of things. But one of the big problems, particularly for SQL, there are two really big problems, actually. One of them is joins. Because you're using a lot of devices, you need to have a distributed join. And when you start running the actual join itself, you need a huge data transfer needs to take place across all those GPU devices. And so with IBM and with Power and the collaboration with NVIDIA for NVLink, you've got this fantastic ability to shift data around a system from GPU to GPU, GPU to CPU, and then across the entire cluster. So that's the one thing that is really important, one of the big challenges. The second thing is, again, the GPUs are great, but you need a huge amount of them to take on board some of the really bigger workloads. And so the next challenge is actually a heterogeneous solution that brings more of the CPU resources into play. And again, it's NVLink that really helps address that problem in a way that just the alternatives are just not able to do.
Mm-hmm. Thanks. Kind of switch a little bit topics here slightly with Ashish and MapD. And I guess you are a founding member of the GoAI initiative. Could you kind of briefly describe what that is and I guess what led you all to develop the new standard?
Sure, thanks. So the GoAI initiative is a GPU Open Analytics initiative. We are a founding member along with H2O and Anaconda. And the premise is really that on one hand, the GPU architecture and processing power is increasing, but there is kind of a disconnect between systems and platforms, because if you have to leverage the CPU in between in the processes, then you basically have that overhead of you're doing something really fast on the GPUs, but then you're passing on to CPUs. So that's really the genesis of the GoAI initiative. And the idea is that three companies came together, MapD, H2O, and Anaconda, to create some open frameworks that we could enable data scientists and analysts to follow so that they can get better throughput. The first project that actually has been released by this consortium is the GDF, the GPU data frame. And the idea here is to have an absolute zero copy interchange. We identify all the processes that can stay on the GPU as much as possible. And we provide an end-to-end framework that allows the data to actually just stay within the GPU realm, leverage the increase in the speed of the memory. And that really provides both the hardware and the software combination of high throughput, both for machine learning and also for accelerated analytics.
Okay. And I guess jumping over here to Vinod, in your opinion, how do you think we can accelerate the enterprise AI adoption? I mean, it's a little.
Sure. So we at H2 have been, working on open source machine learning for over 6 years now. Over 12,000 organizations use this globally. But what we found time and again is there's sort of three main roadblocks. The first is speed to insights. When I mean speed, it's not just about the hardware performance, but also the expertise required to tune algorithms to do the workload, do the feature engineering, as you mentioned. The second is, of course, explaining the results of machine learning algorithms, or AI. So once you create some predictions, the big challenge is you don't understand why a prediction was made. So that becomes a big challenge in adoption. And the final piece is the time it takes for deployment. So even if data scientists are able to, or machine learning researchers are able to build these great models, they don't get deployed to production. So there's a big lag between research and development and going to production. So what we try to do is optimize for all those problems by creating a fully automated solution called driverless AI, which and there's a demo I'd love to show you later in the day, where we have taken the process of the entire machine learning workflow from feature engineering, data prep, and machine learning, doing all of that iteratively. And this is where the hardware acceleration from the power systems becomes really effective, because you're going back and forth from CPU to CPUs, doing the feature engineering on the CPUs and then the machine learning on the GPUs. We also accelerated traditional machine learning algorithms like XGBoost, K-means, GLM, in addition to the deep learning algorithms. And that's all available in the open source and the H204 GPU package. That's part of the Go AI initiative as well. And then finally, providing interpretations for every single prediction you make, agnostic of the algorithms. I think the combination of all three with the latest accelerations from the hardware is what's required for enterprise AI adoption.
Right, okay. That's a good answer. And I guess I've got one last question for Ari, and it's more around Power AI. And I guess what I would like to know is, from, I guess, the aspects, what are the most important aspects, I think, of Power AI from a developer and an MSP perspective?
Well, I think the most important thing about Power AI in the kind of big picture is that it's horribly boring, in a good way. Because, you know, you take the equation of the frameworks you need to do the development and inferencing out of the question. You can get these things up so fast. Let's say you have the baseline Linux, supported Linux installed. It takes about half an hour to install Power AI, and 20 minutes is spent on the downloading from the distribution site. So that's kind of a, and for example, for us, because now we have a highly repeatable product in our hands that we need to push out into the market through the partners. Being able to set up Power AI as the platform for inferencing, as little effort as possible is just crucial. Mm-hmm. No excitement around compiling everything and seeing, okay, this time we grabbed some dependencies that don't work or work differently. It's solid, we have tested everything, and we can just ship it to the partners. Okay, you have the Power Box over there, do this, you're up and running with our solution in 2 or 3 hours. And Power AI automates traditionally a huge part of kind of what you need to do to set up everything.
Well, I better wrap up now. I know we have another keynote coming up after this, but I'd like to thank you guys for taking the time to come up here and answer these questions.